When you hear the word acid, there is there's this immediate, almost visceral association with destruction, right?
Oh, absolutely. It's an inherently aggressive word.
Yeah, like you picture a sci-fi movie where a drop of this glowing green liquid hits the floor and it just sizzles and melts right through the metal hull of the spaceship.
Right. We're basically conditioned by science fiction and, high school chemistry to view acids exclusively as these things that just dissolve, corrode, and destroy everything they touch.
Exactly. We certainly don't picture, casually spraying an acid on our kitchen counters,
Yeah.
or misting it over a cutting board where we're about to chop vegetables for dinner.
No, definitely not.
I mean, I know if you look under my kitchen sink right now, it is basically a hazmat zone of warning labels.
Yeah.
I actually ruined a patch of laminate a few years ago because I left this heavy-duty spray sitting for too long, and it just etched right into the surface.
Oh, wow, yeah. But see, that is the chemical reality most of us live in. If it doesn't burn your lungs a little bit when you spray it, we just assume it isn't strong enough to actually kill germs. Right. But stepping into the world of modern, biologically inspired sanitizers, well, it flips that entire toxic paradigm on its head.
Okay, let's unpack this,
Yeah.
because that brings us to our focus today. For you listening, we are taking a deep dive into an incredibly detailed breakdown from Era Organics.
Yeah, an article by Nikki Chase from April 2026.
Exactly.
Mm.
And the subject is a product with a genuinely intimidating chemical-heavy name, Hypochlorous Acid Disinfectant Spray, or HOCl for short.
It does sound like something from a lab, doesn't it?
It really does. But our mission today is to demystify this solution. We're going to look at the underlying science of how this so-called acid is actually an eco-friendly, non-toxic germ killer that you can, confidently use around your pets, your kids, and even directly on your food prep surfaces.
Which is so important because we are entering an era where we are fundamentally rethinking what the concept of clean actually means. We're moving away from these blunt, destructive chemical instruments toward highly targeted solutions. And the starting point for understanding how HOCl operates well, it isn't in a chemical plant. It's actually inside your own body.
See, that was the detail in the source material that immediately caught my attention. If this stuff doesn't melt the spaceship hull, how does it take out pathogens?
It's a great question.
The article notes that hypochlorous acid isn't something cooked up from scratch in a laboratory to clean floors. It is produced naturally by the human immune system. Specifically, your white blood cells generate HOCl to fight off infections.
Yeah, it is a remarkable defense mechanism. When your immune system encounters a pathogen, it produces this exact compound to neutralize the threat.
Wow.
And its mechanism of action is incredibly precise. When bottled HOCl encounters bacteria, viruses, or fungi on a countertop, it rapidly penetrates the cell walls of the bacteria.
Okay, so it gets right in there.
Exactly. But for viruses, and the source specifically mentions pathogens like adenovirus, hepatitis B, and SARS-CoV-2, it works by directly altering and reacting with their specific protein structures.
Right, and the crucial distinction here from the scientific studies is that it attacks those microbial proteins, but it does not touch the genetic material itself.
Yes, that's a key point.
I was actually trying to visualize the mechanics of this earlier today. If a virus is basically just a string of genetic code wrapped in a protein shell, those exterior proteins are like a highly specific set of keys used to unlock human cells and infect them.
Right.
Yeah.
That is a very accurate way to look at it. The proteins facilitate the entry.
So instead of dropping a chemical bomb that annihilates the entire viral structure, which is what harsh chemicals do, causing massive collateral damage to the surface you're cleaning, HOCl essentially just melts the teeth off the key.
Oh, I like that.
Yeah, like neutralizing a getaway car by simply pulling out the spark plugs, rather than dropping a bomb on the whole vehicle. The virus still has its genetic instructions, its internal hard drive is still there, but its protein keys are completely denatured. It's locked out and rendered inactive.
Exactly. The scientific term is protein denaturation. By changing the shape and chemical makeup of those surface proteins, the pathogen is neutralized. And what's fascinating here is the concept of biomimicry.
Biomimicry.
Yeah. By utilizing hypochlorous acid, we aren't inventing a new chemical weapon. We are simply taking our own immune system's highly evolved, precise defense mechanism and deploying it onto our countertops.
That is just wild to think about, but that raises a massive logistical question for me.
Okay, what is it?
If our bodies synthesize this naturally in white blood cells, how do manufacturers practically scale that up and get it into a plastic spray bottle? Like, they weren't extracting it from people, obviously.
No, definitely not. And the manufacturing process is actually incredibly elegant. According to the ERA Organics breakdown, the active solution requires just 3 core components plus 1 essential stabilizing factor.
Okay, 3 ingredients.
Right. You have the HOCl itself, which is the active germ killer. Then you have water, which serves as the carrier. It helps the active ingredient reach into the microscopic crevices of, say, your computer keyboard or the grain of your cutting board.
Makes sense. And the third,
The third ingredient is simply sodium chloride.
which is just plain salt.
Exact.
So wait, if the base ingredients are just water and salt,
Yeah.
this sounds like they're utilizing electrolysis. Are they basically just running an electrical charge through a saltwater brine?
That is precisely how it's done. You start with a simple saltwater solution. In an electrochemical cell, you pass an electrical current through that brine.
Yeah.
This current literally forces the water and salt molecules to split apart. The sodium chloride separates, and the chloride ions are drawn toward the positive electrical pole, the anode. There, they undergo an electrochemical reaction with the water molecules to form hypochlorous acid.
Wow, that makes perfect sense. The electricity essentially rearranges the molecular puzzle pieces.
Yes, exactly.
But, okay, the source mentions a fourth element in the bottle, pH stabilizers. And I have to play the skeptic for a second here.
Go for it.
If this is supposed to be a triumph of clean biomimicry, just water, salt, and electricity, why are we introducing pH stabilizers? Isn't that just a polite industry term for sneaking synthetic chemicals back into the mix?
It is a vital question, but in this case, the stabilizers are an absolute chemical necessity. Hypochlorous acid is a highly metastable compound,
Metastable, meaning what exactly?
meaning it is inherently fragile and eager to shift into a different chemical state. If the solution isn't kept in a very strict, slightly acidic environment, specifically a pH between 5 and 6, the HOCl just falls apart.
Oh, really? What happens to it if the pH drifts out of that zone?
Well, if the pH drops too low and becomes too acidic, the solution can convert into chlorine gas.
Oh, wow. Which is toxic.
Very toxic, yes. And if the pH goes too high and becomes alkaline, it converts into hypochlorite, which is the primary component of common bleach.
Ah, I see.
And hypochlorite is significantly less effective at neutralizing pathogens than pure hypochlorous acid. So those stabilizers, which are usually very mild buffering agents, hold the solution perfectly balanced on that tightrope between 5 and 6.
So without the stabilizers holding that exact tension, you are basically paying for a bottle of mildly ineffective bleach or just expensive salt water, depending on how it degrades.
Precisely. That delicate pH balance ensures the maximum concentration of active HOCl. The formulation also has to hit a specific concentration to be effective, which the article notes is ideally between 50 and 200 parts per million, or ppm.
Okay, 50 to 200 ppm.
Right. And when you have that concentration locked in at the 5 to 6 pH range, and it is stored properly, meaning away from direct sunlight in a cool, dry place, it remains stable until you need it.
Okay, but because it relies on this incredibly fragile chemical balance to survive, it dictates exactly how you have to use it in the real world, right?
Absolutely.
Because the Air Organics article gets very specific about the application process. You shake the bottle to ensure an even distribution. You hold it 6 to 8 inches away, spray a light layer, and then this is key. You have to just let it sit for 1 to 2 minutes of contact time.
Yes, you don't just spray it and furiously scrub it with a dirty sponge.
Right, you have to let it work. The contact time is critical. It gives the HOCl the physical time necessary to denature those viral and bacterial proteins we talked about earlier. And importantly, it dries rapidly. Within 1 to 3 minutes, the water evaporates, leaving behind absolutely no sticky residue or chemical film. And because it's primarily water and non-corrosive, it's safe for almost anything. You can mist sensitive electronics like phones and keyboards. Just, mist them, don't soak them.
Right, obviously.
It's safe for wood, metal, glass, plastic. It's perfectly safe for food contact surfaces. You can spray your knives and cutting boards without altering the taste or color of your food.
It's incredibly versatile.
But that same fragile chemistry creates what some might view as its one major catch. Once it evaporates, there is zero lasting protection. It rapidly degrades right back into simple water and trace salt.
Which means the antimicrobial action happens strictly at the time of contact.
Right. So I want you to consider this. If you thoroughly sanitize a doorknob and someone touches that doorknob 5 minutes later with contaminated hands, that surface is instantly compromised again. It demands frequent reapplication throughout the day in high-touch areas.
That's true.
And we are so trained by marketing to crave products that promise a 24-hour protective shield. Wait, isn't this complete lack of a residual barrier a massive flaw for a cleaning product?
It's totally counterintuitive to how we've been marketed to, but if we connect this to the bigger picture, that lack of residual protection is actually its greatest feature.
Really? How so?
We have to think critically about what a long-lasting shield actually physically consists of. It is a persistent layer of synthetic chemical residue left behind on your counters and, your kids' toys.
Oh, yuck, when you put it that way.
Yeah, and over time, that chemical buildup does real structural damage. It strips the natural oils from wood, it compromises the integrity of plastics, it causes discoloration, and it creates material fatigue.
Not to mention the constant physical exposure to whoever is touching those surfaces all day.
Exactly. Because hypochlorous acid reverts instantly to harmless water and salt, it never accumulates. You can apply it 50 times a day in a high-traffic office or a busy kitchen without ever degrading your belongings or exposing yourself to a constantly accumulating chemical film.
So it requires more frequent application, but it trades that minor inconvenience for total safety.
Perfectly said. It's ruthless on pathogens, but entirely safe for household surfaces.
That makes sense. It's a team player with the physical materials in your house.
Yeah.
But because it's so incredibly reactive, it is absolutely not a team player with your other cleaning products.
Oh, not at all.
The source material issues a very firm safety warning about this.
Yes, it does. Hypochlorous acid must be kept entirely sanitated from strong acids, traditional bleach, and ammonia-based cleaners.
And here's where it gets really interesting. You have this highly evolved, kid-safe, gentle cleaner. But if you force it to interact with the traditional, harsh chemicals we have relied on for decades, it turns volatile.
It does.
What physically happens if someone sprays HOCl onto a counter that still has a layer of ammonia residue on it?
Well, one of two chemical reactions occurs, and honestly, both of them are bad. At best, the alkaline detergents or surfactants in traditional cleaners will completely destabilize the HOCl solution.
Because of the pH.
Exactly. Remember that delicate pH tightrope of 5 to 6? Ammonia and strong detergents are highly alkaline. They instantly raise the pH, knocking the HOCl off that tightrope and neutralizing its germ-killing ability. You are suddenly just wiping your counter with wet salt.
Wow. And the worst-case scenario.
At worst, the HOCl interacts with the bleach or ammonia residues to produce toxic chloramine gases.
Oh, wow.
Yeah, it's a severe respiratory hazard. Because of this high reactivity, HOCl demands a totally clean slate. You must only apply it to pre-clean surfaces that have been completely wiped free of any other synthetic cleaning chemicals.
That really challenges our deeply ingrained psychological bias when we clean. I mean, we have this more is better mentality.
We really do.
We think if we scrub the bathroom with bleach and then follow it up by spraying an antibacterial compound, we're double killing the germs. But here, layering your cleaners isn't just mathematically ineffective, it actively creates a safety hazard. HOCl requires total chemical isolation to do its job safely.
It forces us to abandon that chemical cocktail approach.
Yeah. And when you do isolate it and use it correctly, its safety profile opens up applications that are frankly staggering.
They really are.
The AeroOrganics article lists multi-industry uses that go so far beyond just wiping down a kitchen cutting board. Let's look at wound care, for instance. It is actively used to clean minor cuts, scrapes, and burns.
Which is fascinating when you consider how traditional antiseptics work. Things like rubbing alcohol or hydrogen peroxide are highly cytotoxic.
Meaning they kill cells.
Right. They absolutely kill the bacteria in a wound, but they also kill your body's own fibroblasts, the very cells responsible for healing and repairing the tissue. So they actually delay the healing process.
But HOCl doesn't do that.
It doesn't, because it is literally an immune system compound. Our bodies recognize it. Human cells have evolved natural antioxidant defenses against hypochlorous acid because our own neutrophils produce it continuously.
Oh, that makes so much sense.
Yeah, so when you spray it on a scrape, it ruthlessly denatures the bacterial proteins, but the human tissue is equipped to tolerate it perfectly. It sanitizes without being cytotoxic to the host.
That is incredible. And it's used in skincare too, right? In facial sprays to target acne-causing bacteria and soothe inflammation.
Yes, for the exact same reason.
And odor control, neutralizing odor-causing bacteria in trash bins and pet areas without using artificial fragrances.
It just neutralizes the source.
And then jumping to a completely different extreme of scale, you have the agricultural sector. Farmers are deploying HOCl to sanitize enormous irrigation systems, to wash freshly harvested fruits and vegetables, and even to purify swimming pools and drinking water.
The mechanism there solves a massive environmental problem. In agriculture, massive irrigation lines develop thick bacterial biofilms.
Oh,
Traditionally, you have to flush those lines with heavy, toxic chemicals, which then run off into the soil, damage the crop root systems, and contaminate the local water table.
right, the chemical residue persists.
Exactly. But with HOCl, a farmer can flush thousands of gallons through an irrigation system, completely strip away the biological pathogens, and within minutes, the compound degrades entirely back into water and a trace amount of salt.
So there is no toxic runoff.
None at all. It sanitizes the environment and then just vanishes.
It's sanitizing the apple you are going to eat without leaving a poison on the skin. Now, I do need to drop a quick note here just to cover the bases from the source material.
Sure.
Era Organics is very clear to state that these commercial products are not evaluated by the FDA to diagnose, treat, cure, or prevent any disease, and it shouldn't be taken as medical advice.
A very necessary distinction. A surface sanitizer from the hardware store is formulated differently and held to different regulatory standards than a medical-grade wound wash, even if the core active molecule is the same. Always consult a medical professional for actual healthcare needs.
Absolutely. But stepping back and looking at the pure science of the molecule itself, so what does this all mean? It's a multi-industry disruptor.
It really is.
The fundamental chemical mechanism that clears out a massive agricultural irrigation line is the exact same active ingredient you can use to scrub a toilet, or gently target an acne breakout, or spray on a child's scraped knee. It bridges household chores, massive industrial farming, and human health care.
It completely collapses the rigid boundary we have constructed between cleaning our external environments and caring for our internal biology.
It really does. We started this deep dive talking about the sci-fi image of acid melting through a spaceship floor.
Right, the glowing green stuff.
Yeah. We were so used to the idea that effective cleaning required a corrosive, toxic weapon. But digging into this Era Organics breakdown reveals something so much smarter. We are looking at a simple, metastable solution of water, salt, and electricity.
A brilliant bit of biomimicry.
Yeah, it relies on a delicate pH tightrope. It melts the protein keys of viruses without touching their genetic hard drives, and then it gracefully degrades into salt water without leaving a trace of chemical fatigue on your belongings or your environment. It really makes us rethink everything we know about sanitizing our homes.
It proves that true cleanliness doesn't require collateral damage. And I think that leaves us with a compelling final thought to consider regarding the trajectory of the products we bring into our homes.
Oh, let's hear it.
If a compound originally generated by the evolutionary brilliance of our own white blood cells is now being scaled up to perfectly sanitize our kitchen countertops, our crops, and our global drinking water supply, are we rapidly approaching a future where our household products are no longer synthetic chemical inventions, but simply scalable extensions of our own human biology?